Hello and welcome to today's video. Today's video is for Chapter 4, Section 3, Triangles and Congruence using angle, side angle, and angle, angle, side. So this one is, ASA, angle, side angle, and angle, angle, side, AAS. Okay, so we have a total of 4 theorems or postulates that we're going to learn in these two sections. We normally do sections 2 and 3 together because all they are is the triangle congruence theorems and postulates. So you probably are watching section 2 video and then section 3. Okay, so the next one we have is angle, side angle, and again it's really important the way the letters are listed. This one is telling me that the side is between the two angles. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So if you take a look at our picture, we're given angles G and K are congruent, angles H and N are congruent, and then the side that we're given is actually the side that's between the two angles. So this would be angle, side angle. So we can say that triangle GHB is congruent to triangle KNP. So for this one, we have which triangle is congruent to CAT, CAT, by the angle, side, angle postulate. Okay, so if we take a look, we have C as our one angle, and if we take a look at our other ones, well first, what I would make sure is the side is between the two angles, so I can get rid of this triangle right off the bat because the side's not between the two angles. So it has to be between these two triangles that they're congruent. So if I match up where they are corresponding, C corresponds to G, A corresponds to D, and T corresponds to O. So it would be C. So the next problem is a proof. Study what you're given and write what you are to prove about the lacrosse goal. Then write a proof that uses angle, side, angle. So this is another one that we're going to do in class. So take a look at it. Write down what you need to be given. Write down what you're proving, and we'll do this proof together. So the last one we have is actually a theorem. Okay. So this one is angle, angle, side theorem. Okay. This is the only theorem in these two sections, and the reason why is because it is basically provable using one of the other postulates. So one of the things I want you to think about, and I'll ask you about it, is which postulate do you think this theorem is based on? Okay? And there's a hint, and I gave you a new theorem in the last section that can help you realize which one it is. Okay, so this one, notice the side is not between the two angles. So this one says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the other triangle, then the triangles are congruent. So this is the one time where we don't have the side in between the two angles. So we have two angles and a side that's not actually between them. Okay, so for this one we can say that triangle DCM is congruent to triangle, oh, they mixed it up on me, GXT. Okay. This is a very quick proof. So the proof of the angle, angle, side, basically once you use one of the theorems that I gave you, you can quickly use another postulate to prove this one. So this will be a pretty quick proof of this one. So take a look at it and we will prove it in class. And then we also have this proof. Study what you're given and what you need to prove. We're given that the lines are parallel, so all that work that we did in Chapter 3 is not going away. We still need to think of like corresponding angles, alternate interior angles, things like that. And we're also given that XR bisects QT, and we want to prove the triangles are congruent. You can use any of the postulates or theorems that we've learned. You can also use definition of congruent polygons if you wanted to, but we want to prove the two triangles are congruent. Okay? So if you want to give this one a try, and we'll talk about it, but we will do this one in class also. Okay. That is it for today's notes. Thank you. Have a great day.